Here I have a Yokogawa differential pressure transmitter connected to a battery-powered circuit where we can measure the signal output by the transmitter by looking at this analog voltmeter. The voltmeter is connected in parallel to a 250 ohm resistor network. This is actually 4 1000 ohm resistors connected in parallel to form an equivalent 250 ohm resistor. The signal output by the DP cell, by this differential pressure transmitter, is 4 to 20 milliamps DC. You can see the connections right here. There's a plus and a minus signal connection, what they label as supply. And these two green wires here connect the transmitter to the terminal strip, where I have a pair of 9-volt batteries in series, providing approximately 18 volts to power the transmitter. The purpose of this demonstration will be to show the difference in function between the high and low pressure ports on the transmitter. If we look at the transmitter itself, we'll notice that down here by the capsule, you see two letters, an H and an L. The H stands for high pressure and the L stands for low pressure. Now this does not necessarily mean that the high pressure side is going to have more physical pressure than the low pressure side. What it does refer to is the direction of response that the transmitter signal will take when it sees pressure applied to either side. So I'd like to demonstrate that now with a piece of plastic tubing. I'll first attach to the high pressure side. This is a temporary attachment, so I'm not going to bother spinning on the compression nut. Now this piece of plastic tubing is connected to the high pressure port or high pressure side of the transmitter. When I apply a positive pressure to that side, we're going to see what the voltmeter registers. If we take a look at the needle as I apply a positive pressure. And we see the signal rise. As I apply a positive pressure to the transmitter, to the high pressure side, it causes the current signal to increase. That causes a larger voltage drop across the resistor network, and our voltmeter registers a higher voltage. I'll show it again. Positive pressure to the high side makes the reading go up. If I take the hose now, the tube, and I move to the other port, the low pressure port, what I find is that the direction of response will be different. If I focus my attention on the voltmeter and apply a positive pressure now to the low pressure port, watch what happens. Notice how the voltmeter reading goes down. As I apply a positive pressure to the low pressure side of the transmitter, it flexes the diaphragm in an opposite direction to which way it was going when pressure was applied to the high side. The transmitter interprets this as a negative pressure, and therefore the 4 to 20 milliamp current signal goes downscale. In fact, even below 4 milliamps if I apply enough pressure to the low side. So once again, positive pressure to the low side drives the signal down. Now we can also use this transmitter to measure vacuums. Watch what happens when I apply a slight vacuum, a negative pressure to the low pressure side. What that will do is it will take the diaphragm of the transmitter and suck it in the direction to the right, which is the same direction the diaphragm will flex as if I applied a positive pressure to the high side. So as we expect, the transmitter will respond in the same manner as it did to a positive pressure on the high side if we apply a vacuum on the low. Watch what happens. You can see it goes upscale. Conversely, if I attach the tube to the low pressure side and apply a vacuum here, that's going to take the diaphragm and pull it to the left, which is the same thing as what will happen as I apply a positive pressure to the low side. So negative pressure or vacuum to the high side is the same as a positive pressure to the low side, and we would expect to see the voltmeter reading go down. So watch what happens when I apply a vacuum to the high side. And as we see, the voltmeter reading does go down. So that explains and illustrates the difference between the high pressure side and low pressure sides of a differential pressure transmitter. Now, if we were using this transmitter simply to measure gauge pressure, let's say we had a process vessel with a positive pressure inside of it, and we wanted to measure that positive pressure, it would make the most sense to connect this impulse line to the vessel to the high pressure side of the transmitter. That way the high pressure in the vessel would drive the diaphragm in that direction, causing the reading to go upscale. On the other hand, suppose we had a process vessel that contained a vacuum, a negative pressure. and we wanted a stronger vacuum in the vessel to cause the reading to go upscale. What we would do is attach our impulse line to the low pressure side. That way, a stronger vacuum, a stronger negative pressure in the impulse line would cause the diaphragm to flex the same direction as a stronger pressure on the high pressure port, and that would cause the reading to go upscale.